Hey everyone, today we're basically starting a construction project. But we're not going to be using bricks or wood. We're going to be using pure logic to build something completely unshakable, certainty. And our entire construction site? It's the world of geometry.
I mean, really think about that. In a world that's just full of opinions and noise, how can you prove that something is absolutely 100% undeniably true? Well, for centuries, geometry has been the gold standard for doing exactly that. It's so much more than just triangles and circles. It's a perfect system for building an argument from the ground up until it's totally ironclad.
So, here's our blueprint for the day. We're going to start with the absolute basics, then we'll define our tools, learn the rules of the game, and then, this is the fun part, we'll use all of that to construct our very own logical proof, step by step. All right, let's get into it.
First up, the certainty of shapes. This is all about laying the foundation for our logic. I mean, before you can build any kind of argument, you have to agree on the most basic, fundamental materials you're even working with.
Now, what's kind of wild is that in a system that's built on perfect definitions, we actually have to start with things we can't formally define. We call them undefined terms. We can't prove what they are. We all just have to kind of nod and agree on what they mean so we have a common place to begin.
So our first undefined term is the point. Just think of it as the absolute atom of our geometric universe. It has no size, no dimension, no depth at all. It's just a location. It's the simplest possible idea you can imagine.
Okay, so from points, we get our next undefined term, the line. It's got one dimension, length, but it has zero width, and, this is key, it extends infinitely in both directions. The line you see on the screen is just a symbol. The true perfect geometric line is an idea that just goes on forever.
And finally, to round out the big three, we have the plane. This is a perfectly flat surface with two dimensions, length and width, that also extends infinitely. Think of it like a never-ending sheet of paper. So, the point, the line, and the plane. Those are our three fundamental, agreed-upon starting blocks.
All right, let's move on to our next section, geometry's basic tools. Now that we have our raw materials, we can start crafting them into components that we can actually use.
You see how this works? We use our undefined terms to create defined terms. So if you have a bunch of points that all lie on the same line, boom, we call them collinear. If you take just a piece of a line and give it a start and an end, you've just created a line segment. We're already building simple structures from our most basic ideas.
Okay, so we've got our materials and some basic tools. Now for the really crucial part, the rules. In geometry, we have two kinds of rules, and trust me, knowing the difference between them is everything.
This slide just lays it out perfectly. A postulate is a rule we all just accept as true without needing any proof. It's a fundamental law of our geometric world. A theorem, on the other hand, is a rule that we have to prove is true, and we do it by using our postulates and definitions. So think of it this way. Postulates are the rules of the game. Theorems are the awesome plays we prove are possible within those rules.
Here's a perfect example of a postulate, the segment addition postulate. It basically just says that a small piece of a line segment plus the other piece of that segment equals the total length. I mean, it seems obvious, right? And that's exactly what makes it a perfect postulate. It's an official rule of the game that we all just agree on because it's common sense.
Now, before we build our proof, there's a quick but really important note on language. In geometry, numbers can be equal, but the shapes themselves are congruent. It's a small distinction, I know, but this kind of precision in how we talk is the bedrock of any solid logical argument.
And now, the moment we've been building toward. We are going to take our undefined terms, our definitions, and our postulates, and we are going to construct an absolutely unbreakable logical proof for our very first theorem, the midpoint theorem.
This right here is our toolkit. To build a proof, every single statement we make, every single one, has to be justified by one of these four things. The information we're given to start with, a formal definition, a postulate, or a theorem we've already proven. No opinions, no guesses allowed. Just cold, hard logic.
Okay, let's walk through this construction. We start with our given info. M is the midpoint of segment AB. That's statement one. Simple enough. So from there, what do we know? Well, by the very definition of a midpoint, we know it splits the segment into two equal parts. So AM equals MB. That's statement two. Next, we use one of our rules, the segment addition postulate. We know that the two parts, AM and MB, have to add up to the whole, AB. Now for the clever move. Since we know from step 2 that AM and MB are equal, we can use the substitution property to just replace MB with another AM. And finally, a little algebra, the division property of equality, and we get to our conclusion. The length of AM is exactly half the length of AB.
And we've done it. We didn't just assume this was true. We built an unbreakable chain of logic where every single link is justified by an established definition or rule. We have proved the midpoint theorem. That's awesome.
So let's just step back for a second and admire what we've built here. We literally went from a simple, fuzzy idea to an unshakable, provable conclusion. And this visual really captures the entire process. It's a ladder of logic. We started on that bottom rung with those simple, undefined ideas. We used them to climb to the next rung of clear definitions. Then we used our accepted rules, the postulates, to build a logical structure that let us reach all the way to the top and prove a brand new truth, a theorem.
So what's the real takeaway here? This isn't just about geometry, right? This is about a way of thinking. It's about starting with what you know, defining your terms, following the rules, and building a conclusion that no one on Earth can argue with. So the real question is, if this system of logic can build a world of total certainty with shapes, what can it help you build in yours?